Good morning. Hello, everyone. Welcome back. So in this video, I'm going to show you how to graph a polynomial function in standard form. And what is particular about this polynomial function is every exponent on the variable x is an even number. You have 4, 2, and 0. Okay. So now let's start. So what is the degree? The degree represents the highest exponent. Okay, so here the highest exponent, since it's already written in standard form, from highest exponent to the lowest, so the highest exponent is the first one. So it's the degree is a 4, but I don't really care about the number. I only care if it's even or odd. So here, because 4 is an even number, I will say the degree is even, right? And SOTLC stands for sign of the leading coefficient. So the sign of the leading coefficient means what is the sign in front of the leading term? So the leading term here is the term of the highest exponent, which is x to the 4th power, okay? And what is the number in front of it? If you don't see the number again, it's not 0, but 1 times x to the 4th power. Since 1 is positive, I'm going to write for the sign it's positive 1, okay? There's no negative in front, so we assume it's positive. Now let's describe, to describe the end behavior, using our notation, I'm going to show you the end behavior visually. So since it's a positive, so means arrows on the right needs to point up. And since you have even degree, the arrows have to point, both arrows needs to point toward the same direction. So since they're positive, both arrows point up. Now, I can use this visual end behavior to describe in arrow notation the end behavior. So on the left, I'm going to describe as the x value approaches negative infinity, comma, the y value approaches positive infinity. Why? Because as the x value becomes more negative, the y values, you can see the arrow is pointing up, okay? You take a number and you raise it to the 4th power. Again, it's going to be more negatives, not ups, more positive. So now let's move on to the on the right side. So as the x approaches positive infinity, as the x value becomes bigger and bigger and bigger, what is happening to the y value? So the y value is also getting bigger because the arrow is also on the right is pointing up. Okay, so we are done describing the end behavior. And again, the y-intercept represents the point when x is 0. Okay, what is the y value? When x is 0, the y value is 9. So the y-intercept is 0, 9. And to identify the 0 means we want to figure out when y is equal to 0. So when the y here is equal to x to the 4th power minus 10x squared plus 9 is equal to 0. Okay, so I'm just going to rewrite. Okay, so we want to find out when what is the x value when y is 0. So I just rewrote the equation without the y. So now here it's going to be similar to what I've shown you before with solving quadratic equation. Okay, it's the same principle. So what you want to do here, okay, you want to see if it's a quadratic equation. This I don't know, this quadratic equation is factorable. So what I'm trying to say, can you think of two numbers that add to and multiply to? So can you think of two numbers that multiply to 1 times 9 is 9, and the same two numbers needs to add up to negative 10. Okay, can you think of two numbers that multiply to 9? Always start with the product. Multiply to 9 and add to negative 10, the middle terms. Okay, so I hope you found the number, and the number is going to be, I believe, negative 1 and negative 9. Okay, negative 1 times negative 9 add up to positive 9. Negative 1 plus negative 9 add up to negative 10. Check, check. Okay, so what I'm going to do next, so we are going to replace, so I'm going to replace the middle terms with what number? With negative 1x squared and negative 9x squared plus 9. So I replace negative 10x squared with the two middle terms. But instead of using x, I'm using x squared, okay? Because the equation is not quadratic, it's not quadratic, but quadratic, but the principle is the same, okay? So now you can use the box method by grouping. So I'm just going to use the box method. because I know most of you use a box. Okay, so here you write x to the 4th power. So remember, always write the leading term on the top left and the constant on the bottom right square. And then right here on the diagonal, write the middle terms. So now you're going to factor out each rows. So here, the greatest common factor that I have here is going to be x squared. The second row is going to be -9. Right here, the greatest common factor for the first column is x squared. The second column is going to be -1. So let's check x squared times x squared is x to the 4th power. X squared times -1 is -1x squared, check. -9 times x squared is -9x squared. -9 times -1 is +9, okay? So we are done factoring. So the factor is going to be the one on the expression on the sides. So what is going to be the factor form? The factor form, let me write it here. It's going to be x squared minus 9 times x squared minus 1, everything equal to 0. So now I want you to realize here, okay, you're doing the difference of the 2 square, the difference of 2 square. Why? 9 is a perfect square as well, 1. I can rewrite it as 9 like this. And I show you how to factor the difference of 2 squared, okay? So how do we factor it? So the first factor is going to be made up of 2. So you're going to be x minus 3 and then x plus 3. So make sure you use opposing sign inside the factor so the middle term can be cancelled. Now for the second factor, you're going to have also two factor as well. Okay, then you're going to write here x minus 1 and then x plus 1. You're just dropping the exponent when you factor it. So you're going to apply the zero product property. Okay, I took each factor and set it equal to 0, and then you want to solve for x. Okay, after solving for x, I found that the zeros are here because the solution are real rational numbers. We say that we do have 4 X-intercepts. So which one is at 3, -3, +1, and -1. Okay, now let's do the domain. Like I explained earlier, the domain for every polynomial or any polynomial is always going to be all real numbers. So all real numbers in notation in interval notation goes from parentheses, -infinity, comma, +infinity, and you close the parentheses. Okay. Then for the range, I am going to wait until you graph it to identify the range, because the range for even degree polynomial is not the same as the odd degree polynomial. Odd degree polynomial, we say it's all real number, but that's not the case for even degree. Okay, so the degree here is even, so it's not the same. It's not all real numbers. So because yeah, I'm now going to show you shortly. Okay, let's start sketching the polynomial. So I'm going to label the y-intercept, and remember you identify the y-intercept to be at 0,9. Okay, and then 0,9 is going to be, let me see if I can use 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm going to use 9 here. So 2, 4, 6, 8, 9. Okay, so the y-intercept is at 0,9. Okay, and then you have the x-intercept at that -3 is right here. And then you have -1 right here. And then you have 1. And then +3. Okay. So now we know both are the zeros. Okay. And the end behavior for the even degree is going to be like this. I like to draw this so I know how to start. So you're going to go, and all zeros, all x-intercept are single roots. There's no double nor triple roots. So it's going to be, the polynomial is going to cross over the x-axis at those given x values. So now we know that relative extremas occur between the zeros. Okay, so I know there's going to be one relative extrema between -3 and 1, which is about -2. So I'm just going to find how high to go for the bump, or how low to, here is going to be how low. To find out how low to go, I'm going to evaluate f of -2. Okay, for here, you have f of 0. We already know is 9. And f of, here is going to be f of positive 2. So let's do that on the left side. Okay. Okay, so I just want to find out when sketching the polynomial, okay, I just want to find out how low to go. And I realized that f of negative 2, the output is negative 15. So my scale, I'm going to change my scale on the y-axis. So instead of using 1 square to represent 1 unit, I'm going to use 1 square to represent 2 units. So everything can fit. So it's going to be here 2, 4, 6, and then you have 8, 10, 12. So 9 is not going to be right here. Okay, because the lowest y value is going to be 15, so I need to fix that. Sorry. So then here you get negative 2, negative 4, negative 5, oops, negative 6, negative 8, negative 10, negative 12, negative 14, and negative 16. Let me double check. 2, 4, 6, 8, 10, 12, 14, 16. So negative 15 is going to be right here. So when x equal negative 2 is going to be right here. It's going to be the same also for f of 2, which is also negative 50. Oops, it should be right below. Okay, so now you're going to connect the dots. So I'm going to make sure that as I'm doing this, okay, so you have a bump here. This is one relative axioma. Single root means the polynomial needs to pass through it, and then the polynomial needs to pass. So I can make it better here. Okay, and that you're done graphing the polynomial. Okay, so again, and both arrow point ups, the y-intercept is at 0.9, and you make sure that the polynomial, there's a single, you have 4 single roots, so the polynomial must cross over. Okay, so now we can go back to the range. So you see that the lowest y value that the polynomial can have is right here at negative 15. You always say from the lowest to the highest for the number when you write in interval notation. So you start with negative 15, and both arrows are pointing up. It means the polynomial can have from negative 15 any y values. So I mean going up forward, so it should be positive infinity. So and because the y value can be negative 15, so I'm going to use a bracket for positive infinity or parentheses. Okay, and that's it. So thank you for watching my video, and I hope it was beneficial to you. Thank you. Bye-bye. Have a nice day.